Hey everyone, welcome back to my channel. Today we're going to tackle a hard problem on LeetCode. It's called Number of ZigZag Arrays 2. This problem requires some dynamic programming skills and a solid understanding of how to maintain the state of a sequence. So let's dive in and see how we can solve it. The problem asks us to find the number of valid sequences of length n, where each element is within a given range from lower to upper. And the sequence must have a zigzag pattern, meaning that each element must be different from its neighbors and the sequence must not be strictly increasing or decreasing. Sounds like a tough one, but don't worry, we'll break it down step by step. To solve this problem, we need to understand the core insight, which is that a valid sequence can only be formed by appending a number that is different from the previous one and doesn't create a strictly increasing or decreasing sequence. Think of it like a zigzag line, where each point must be above or below the previous one, but not in a straight line. We can use dynamic programming to track the number of valid sequences ending with an increasing or decreasing trend. Now that we have the intuition, let's walk through the approach. We'll use a 2x2dp array to store the number of valid sequences for each trend, increasing or decreasing, and each possible difference between the last two elements. We'll fill the dp array for each number in the given range, considering the transition from the previous state. And finally, we'll update the dp array for each number by considering all possibilities that can extend the current sequence while maintaining the zigzag property. Let's take a look at the C++ code. We start by defining a 2x2dp array, dp, where dp 0, 0 represents the number of valid sequences ending with a decreasing trend and the last two elements have a difference of 1. And similarly for the other three cases. We then iterate over the range from lower to upper. And for each number, we create a new dp array, new dp, to store the updated values. We check if the current sequence is the first one. If so, we initialize the new dp array based on the given range. Otherwise, we update the new dp array based on the previous state. We then update the dp array with the new values. And finally, we calculate the answer by summing up all the valid sequences for all numbers in the given range. The time complexity of this solution is O n times r minus l plus 1. However, since we actually calculate for each possible number in the range only once, the actual time complexity simplifies to O n times r minus l plus 1. The space complexity is O 1. Which means it uses constant space, because we only use a fixed size dp array, regardless of the input size n and range L to R. That's it for today's problem. I hope you guys enjoyed it and learned something new. If you have any questions or comments, please let me know. Don't forget to like the video, subscribe, and comment your approach below.